Welcome back, everyone. I'm Jordan Giesige, and this is The Limiting Factor. Elon Musk wants to build 1 terawatt of compute for artificial intelligence, which is roughly equivalent to the total power output of the entire U.S. electrical grid. For me, that immediately raises 3 questions, which I'll cover in today's video. First, exactly what type of compute is Elon referring to? That matters because it dictates where the compute will be located and how it'll be powered. Second, the easiest way to power new data centers is to just plug into the grid. But how much more compute can the current grid support? Third, if the grid becomes the limiting factor for compute growth, the next best way to power AI data centers appears to be for tech companies to build their own electricity generation off-grid, and in the not-too-distant future to build data centers in space. Why is that the case, and what are the benefits of those options? Before we begin, a special thanks to my Patreon supporters, YouTube members, and Twitter subscribers, as well as Rebellionaire.com. They specialize in helping investors manage concentrated positions. Rebellionaire can help with covered calls, risk management, and creating a money master plan from your financial first principles. Let's start by understanding what type of compute Elon is referring to for the 1 terawatt of compute. First, he recently clarified that it's for coherent training compute. What does he mean by coherent training compute? Training an AI model involves running huge amounts of data through data centers that contain thousands and soon to be millions of GPUs for days, weeks, or even months. Another way to think of those data centers is that they're AI factories. But instead of building physical products, they're building software products, digital brains known as AI models. For the foreseeable future, the intensive nature of training compute means that it's best done in large, centralized facilities. That's because the farther the data has to travel, the more power it takes, and the longer it takes to move it around. So it's just more efficient to do it under one roof. However, Elon also recently said that distributed compute for inference will probably be over 90% of compute on Earth's surface, meaning that the aforementioned 1 terawatt of training compute would be accompanied by another 9 terawatts of inference compute. Inference compute is used to run the AI models after they've been trained. It can be centralized like it is with Grok, where your query goes to an inference data center, or it can be distributed in products that range from the AI chips now being used in smartphones to the self-driving software used in vehicles to humanoid robots like Optimus. Elon's post is saying that most inference compute on Earth will be distributed, which makes sense given that there will be tens of billions of those devices. What that implies is that outside of Elon's goal for 1 terawatt of centralized coherent training compute on Earth, he's also preparing for much more compute that's decentralized and dedicated to inference. And beyond that, he's thinking even bigger with space-based compute, where he wants to set up Earth to become a K2 or Kardashev Type 2 civilization that utilizes all the power of the sun, effectively making our solar system sentient. To achieve that, it's going to involve not just 1 terawatt of compute in total, but 100 terawatts of compute per year, mass-driven into orbit from the moon. In this video, I'm going to focus mostly on the 1 terawatt of terrestrial coherent training compute, which is ambitious enough, but I will go deeper into the topic of space-based compute in future videos. Now that we know the type of compute needed, centralized training, the next question is, how much more compute can the current U.S. grid support? Let's pick up where we left off in my Wars Are Won with Logistics video. In that video, I showed that Elon's xAI is currently sourcing power for their Colossus 1 and 2 data centers from a combination of mobile gas generators, megapacks, fixed gas generation, a solar farm, and substations, meaning a grid connection. Why does that matter? Because even with all the generation they brought in, Colossus 1 and 2 are still likely getting most of their power from the grid. First, for Colossus 1, most of the gas generation was temporary and could only be used for a year due to local regulations, and some of it will remain as backup power. Second, the main purpose of the megapacks is to buffer the power swings caused by the data center. And third, the solar farm likely covers less than 1/3 of the power usage of the Colossus 1 data center, less than 100 megawatts of solar generated versus around 300 megawatts needed. So for Colossus 1, that leaves the grid connection as the primary source of power. But what about Colossus 2? It's been reported that Elon is importing a 2 gigawatt power plant to supply all the power needs of that data center. The question is, are those reports accurate? In my view, no. Let's take a look at why. Dylan Patel of SemiAnalysis stated in July that XAI bought a power plant overseas, deconstructed it, and shipped it to Memphis, Tennessee for their Colossus 2 data center, which Elon confirmed. Then, Tom's Hardware did an article and estimated that with 1 million GPUs, the Colossus 2 data center would need 2 gigawatts of power. From there, people jumped to the conclusion that because Colossus 2 needs 2 gigawatts of power, that the power plant must be 2 gigawatts. What's the reality? The best analysis I've seen so far indicates that Colossus 2 will likely need around 1.4 gigawatts of total power by early 2026, which I suspect is for the first 550,000 GPUs. Then, when fully completed, Colossus 2 is expected to use around 1 million GPUs, which could mean around 2.8 gigawatts of power demand. That's more than Tom's Hardware's estimates because Tom's likely failed to take into account overheads for things like thermal management and lighting. Either way, 2.8 gigawatts is roughly the output of 3 full-size nuclear reactors, and those aren't easily packed up and shipped overseas, so a combined cycle gas turbine power plant is more likely. However, the largest combined cycle gas turbine in the world is 850 megawatts for a single unit, and the average is more like 700 megawatts per unit. Given that the location where XAI plans on rebuilding the imported power plant was previously the site of a 640 megawatt Duke Energy natural gas generator, it's probably in the ballpark of 600 to 700 megawatts. That's far short of the 1.4 gigawatts needed within the next few months for Colossus 2. Yes, XAI could have more generators on order, but there's been no reporting so far to indicate that. If that holds true, like Colossus 1, most of the power needed for Colossus 2 will need to be supplied by the grid. So if XAI and other AI companies continue to be net importers of power from the grid, how much longer can the grid support their massive scaling ambitions? Currently, the U.S. grid has at least 98 gigawatts of spare capacity if data center operators are willing to reduce or curtail their power usage 0.5% of the time during peak demand periods, about 44 hours per year. That can be done by programming the data centers to use less power during the curtailment periods, or by building a small amount of battery storage on site like Tesla does. An agreement where the data center operator is willing to curtail their power usage is called a Flex Connect agreement. Interestingly, there is potentially more than 98 gigawatts of power available with Flex Connect agreements, but it's a case of diminishing returns. In order to roughly double the available power from 98 gigawatts to 250 gigawatts, the amount of curtailment required increases tenfold from 0.5% to 5%, which in practical terms would mean curtailing for 440 hours per year or having 4 to 6 hours of battery backup instead of 1 to 3 hours. That is, realistically, there's about 100 gigawatts of spare capacity on the grid that's readily accessible, and up to 200 gigawatts if the data center operator is willing to accept more potential disruption or higher costs. As a side note, in a previous video I said that AI data centers require almost 100% utilization rate. That turned out to be incorrect. As Tyler Norris points out here, training data centers have fairly high utilization rates of around 80%, and inference data centers have a much lower utilization rate of around 40%. That may provide some additional flexibility on the data center end when it comes to Flex Connect agreements. If 100 to 200 gigawatts of additional power is readily available with curtailment, what would the upper limit be? The U.S. grid has about 1 terawatt of power capacity and is about 50% utilized, meaning that the output could be doubled with enough curtailment and/or energy storage. Could that doubling be a quick hack to reach the 1 terawatt of compute for Elon's ambitions? In my view, no. That's because it would require curtailing for much more than 440 hours per year or much more than 6 hours of battery storage. That is, the curtailment and battery backup costs quickly become, respectively, too disruptive or expensive to be commercially viable. Regardless, globally, 300 gigawatts of AI power demand is expected by 2030. If we assume that 100 gigawatts of that is for the U.S., then that demand could be satisfied by simply using curtailment or a small amount of battery backup. That places 2030 as a soft wall for building out AI data centers that are heavily reliant on grid power. I call it a soft wall because there's no reason why tech companies couldn't just continue focusing on building out on-grid data centers, and some will, but I think most won't. That's because in the next 3 to 5 years, building on-grid will become increasingly painful, making going off-grid increasingly appealing. Why? First, data centers are seeing increasing pushback from the public, leading to delays and cancellations. Second, because on average, it takes about 18 months to build a data center, whereas to build new electricity generation on-grid, it takes 5 years, which makes a generation bottleneck inevitable. It is true that the current administration is trying to clear that red tape, potentially reducing wait times for large loads to connect to the grid by years. But it will still be easier from a regulatory perspective to build off-grid on private land in Texas, for example, where deploying new generation really comes down to how fast a company can build it. While that does mean a lot more work on the part of the company building the data center, they would have to build their own grid. It would allow them to build data centers more quickly and with more certainty. Furthermore, they could generate their own power for cheaper than they could purchase it from the grid. How is that possible? 2 reasons. First, transmission and distribution costs can make up to 2/3 of the cost of electricity from the grid. Transmission and distribution is the high-voltage power lines, transformers, and lower-voltage power lines that carry the electricity from the generation source to the customer. If a company builds its own grid, they can cut their electricity costs by over half, simply because they no longer have to pay for what's, in effect, the extension cord that can run hundreds of miles from the generation source to the customer. So by 2030, I expect most of the large AI companies will start building their data centers off-grid with dedicated power generation. There will still likely be a grid connection, but it will instead be used as a backup power source and to sell power into the grid if there's excess generation. A second reason why it might be cheaper to build off-grid is because for the massive data centers planned, which are now exceeding 10 gigawatts, and especially for Elon's vision of 1 terawatt data centers, it would simply be easier to build co-located power and data center complexes on large, uninterrupted pieces of land in less populated areas like the southwestern United States. For example, Colossus 1 and 2 were built within the city limits of Memphis, Tennessee, on separate sites. It was a piecemeal approach where the data centers had to be shoehorned into the sites that were available and near the necessary infrastructure. That fragmented approach could become a drag on scaling when the data centers grow to be orders of magnitude larger. Speed and cost are driven by reproducibility. Building on one large plot of land would allow for that by taking a modular approach. What do I mean by that? A large plot of land would allow for a series of rolling construction projects on the same site with identical buildings. When one building is complete, the workers could just move on to the next building. That has benefits for not just construction, but would also have an additive effect for training and coherence. Imagine if Colossus 1 and 2 were built adjacent to each other on the same piece of land rather than across town from each other. The two data centers could potentially be networked together to create a coherent Colossus 1+2 data center. That would also make it much easier to achieve a 1 terawatt data center. That's because instead of starting from zero with each new data center, the new compute added from each new data center would be cumulative. But what's the ultimate off-grid solution? Outer space. Elon recently said that Starship could deliver 100 gigawatts per year to high Earth orbit within 4 to 5 years if they can solve the other parts of the equation. What parts of the equation is he referring to? Making lighter solar panels, radiators, and compute. Solving all of those problems, along with Starship, is just a matter of time and engineering, and it could happen by 2030. However, it would take hundreds, if not thousands, of launches to put 100 gigawatts of compute in orbit each year. For reference, even after about 15 years, Falcon 9 is only doing about 150 launches per year. Yes, Starship will be fully and rapidly reusable, and SpaceX will be mass-producing Starship, but we don't yet have a Starship that's in commercial use, so hitting hundreds or thousands of launches per year by 2030 seems like a stretch goal. To be clear, I'm not putting down that stretch goal, and I'm glad Elon creates them. But as much as possible, I try to set reasonable expectations for myself and audience rather than to generate hype. So in my view, space-based compute won't be putting up gigawatts of compute until after 2030. However, in the long term, it's going to be the most important source of compute. Why? Because there's effectively an infinite volume of space to fill with solar and compute, and vast amounts of power available from the sun. As I said in the first video of the series, humans have infinite wants, and that means an infinite demand of power and compute needed to do useful work to satisfy those wants. So, expanding into outer space is the next logical step for us as a species. Beyond that, in terms of the technical challenges and practical implications of space-based compute, I'll have to get into that in future videos. It's something that I think Elon has already committed to and that he's already actively preparing for. For example, he said that Tesla's AI-8 chip will be out of this world, which means that it's likely being designed with space applications in mind. In summary, the 1 terawatt of compute that Elon mentioned earlier this year appears to be just the tip of the iceberg. Elon has his sights set on Kardashev 2, meaning the journey he's embarking on with compute isn't just a multi-year or a multi-decade project, but potentially a multi-century project. And with each passing month, he's revealing more of his vision. That means this video series, originally conceived as a 2 to 3 part series, will now likely become open-ended to provide updates and insights as Elon gets deeper involved in energy storage and generation, chip manufacturing, and a new industry devoted to building data centers in space. But first things first, in order to understand where everything is headed, we need to understand the current state. As I stated in today's video, the current limiting factor for compute is the power generation limitations of the grid. Extra headroom can be created by curtailing power use at critical times, using battery packs, and fortifying the data center or local grid with power generation like solar and gas. However, data centers can be built 3 times more quickly than power generation. So unless major changes are made to energy regulations, curtailment appears to be a stopgap solution rather than a long-term solution. If that's the case, the large players in the AI game will likely find it easier to scale their data centers by generating their own power off-grid, which removes the scaling constraints of regulation and eliminates transmission and distribution costs. With all that in mind, what's the best mix of technologies to generate Elon's first terawatt of compute? I'll cover that in the next video of the Terawatt Compute series. As always, please consider supporting the channel with the links in the description, which now also includes a referral link for Signature Solar. If you use that link to purchase home battery or solar equipment, it nets me a small percent-based credit, but that can add up on a large purchase and it really helps the channel. On that note, a special thanks to my YouTube members, ex-subscribers, and all the other patrons listed in the credits. I appreciate all of your support, and thanks for tuning in.